Hello students, today we will be looking at exercise 7.5 in the chapter Applications of Differential Calculus, the Tamil Nadu 12th Board Mathematics. So this exercise deals with limits of a function that are in indeterminate forms. So what these indeterminate forms are, you will look in the exercises. So the rule which we'll be using for this exercise is the L'Hopital's rule. That is, suppose we have a function f of x and g of x as differentiable, and g prime of x is not equal to 0. Then with limit x tends to a, f of x is equal to 0, limit x tends to a, g of x is equal to 0. Then we have the limit x tends to a, f of x by g of x. So this is of the form 0 by 0. So when it is of the form 0 by 0, we cannot evaluate the limit. But with this L'Hopital's rule, we are able to get a value in the following manner. That is, we have limit x tends to a, f dash of x by g dash of x. That is, we differentiate the numerator and differentiate the denominator and then evaluate the limits. Similarly, the second possible scenario is the infinity by infinity form. That is, if limit x tends to a, f of x is plus or minus infinity, and limit x tends to a, g of x is also equal to plus or minus infinity. And then the limit of f of x by g of x as x tends to a is given by limit x tends to a, f dash of x divided by g dash of x. So this is also solved by differentiating the numerator and the denominator. The next possible set of problems which we can get is indeterminate forms which are of the form 0 to the power of 0, 1 to the power of infinity, and infinity to the power of 0. So in order to evaluate these forms, there's a theorem which we will be using, that is, let limit x tends to a g of x exist and let it be L, and let f of x be a continuous function at x equal to L. Then limit x tends to a, f of g of x is equal to f of limit x tends to a, g of x. That is, we are interchanging the composite function and the limits. So we take the limit inside and then apply the function f. So with this, we use this procedure with logarithms. That is, we define the function a equal to limit x tends to a, g of x. Then we take the logarithm assuming a greater than 0 to ensure continuity of log function. And then we get log of a is equal to limit x tends to a, log of g of x. So using the above theorem, we have the limit that limit x tends to a, log g of x is equal to logarithm of limit x tends to a, g of x. So this way we're interchanging the limit and the logarithm functions. Now we have the limit x tends to a, log g of x into either 0 by 0 or infinity by infinity form, which we evaluate using the L'Hopital's rule we discussed in the previous section. Once the limit is evaluated, then the solution is e to the power of alpha. So in exercise 7.5, I'll be looking most at the question number 5, question number 7, and question number 10. This will give us a good idea of the different variety of problems that come under the L'Hopital. So limit x tends to infinity e to the power minus x to root x. So we see that the function, the first term e power minus x, that when you have e power minus infinity, it is tends to 0. So it is of the form 0. Whereas the second term, which is the root of x, we take the square root of infinity is infinity. So it is 0 into infinity. Now I'm going to apply the L'Hopital's rule, for which we have to bring the function into the 0 by 0 or infinity by infinity. So in this case, I'm writing e power minus x in the denominator as e power x and the numerator is root of x. Now to apply the L'Hopital's rule, I'm going to differentiate the numerator with respect to x and also the denominator with respect to x. So when I differentiate the numerator, I get 1 by 2 x power minus 1 by 2, and the denominator, when you differentiate with respect to x, we get e power x. Now the function has that 1 in the numerator and 2 root x e power x in the denominator, and we know that root of x is infinite, infinity is infinity, and e power infinity is infinity. So the limit of this function tends to 0. Now the next question is limit x tends to 1 plus, that is, it is tending to 1 from the positive direction, and the function is 2 by x square minus 1 minus x by x minus 1. So when we substitute x to 1, we have the form 2 by 0 or infinity, and the second term is also like 1 divided by 0, which is infinity. So it is of the infinity minus infinity. To apply the L'Hopital rule, we have to bring it to the 0 by 0 form. So what we have is simplify this expression, rewrite it as when we do this addition of these two terms, we have x minus 1 coming here and x square minus 1 coming from this denominator here. So it is 2x minus 2 minus x cube plus x, and denominator when we simplify gives us x cube minus x square plus 1. So in the numerator I have minus x cube and then plus 3x minus 2. When we substitute 1, what we get is 1 cube minus 1 cube plus 3 into 1 minus 2. So the numerator is 0. The denominator is 1 square, 1 cube minus 1 square minus 1 plus 1. So this also is 0. So it is of the 0 by 0 form. And to evaluate this, we'll apply the L'Hopital rule. So I differentiate the numerator, and when I differentiate the numerator, I get minus 3x square plus 3 here, and the denominator is 3x square minus 2x minus 1. Now again, what we see is if I substitute 1, what we get is minus 3 plus 3 is 0. The denominator is 3 minus 2 minus 1, which also gives us 0. So as it is of the 0 by 0 form, again we have to apply the L'Hopital rule and differentiate the numerator. So when I differentiate the numerator, I get minus 6x. So the denominator is 6x minus 2. And when we go from 1 plus, it is the limit we tend to 1 from positive direction, I get minus 6 into 1 divided by 6 into 1 minus 2, which gives minus 6 by 4 or minus 3 by 2. Also, the simpler form of solving this. So this is the final solution limit. But to solve it, a simpler solution, what we can do is 2 by x plus 1, x minus 1 minus x minus 1. So we take x minus 1 common outside and then do the addition. So this will give the solution in one application of L'Hopital. So this is question number 10. So here we have the limit extends to pi by 2 sin x to the power of tan x. Now we know that sine of pi by 2 is 1 and tan of pi by 2 is infinity. So this function is of the form 1 to the power of infinity. For this, we will use the logarithmic way of evaluating the function. So we have let g of x equal to sin x to the power of tan x, and then I take the logarithm. So log of gx gives us tan x comes outside, tan x into log of sin x. Now when I apply the limit extends to pi by 2 log of gx. So I keep log of sin x in the numerator, and for the denominator we write it as cot x because 1 by tan x is cot x. Now sine of pi by 2 is 1 and log of 1 is 0, and the denominator we have cotangent of pi by 2. So cot of pi by 2 is 0. So this is the form 0 by 0, and now we can apply the L'Hopital rule. So in differentiating the numerator log sin x, we use the chain rule. So the first time it gives us 1 by sin x, and then differentiating sin x, it gives us cos x. Whereas the denominator, when we differentiate cot x, gives us minus cosecant square x. Now cosecant is 1 by sin x, so we have sin square x in the numerator, and then after cancelling out, what we get is cos x into minus sin x. Now in the limit pi by 2, it becomes cos of pi by 2 into sin of pi by 2, so which is 1 into 0, which is 0. Now the next step is we have evaluated limit extends to pi by 2 log g of x is equal to log of limit extends to pi by 2 g of x. So we have evaluated the function on the left hand side. Now we are looking for the function on the right within the logarithms. So the LHS is 0. So applying the inverse of log, which is exponential, this the function which is inside, that is equal to e to the power of 0, which is equal to 1. So with this expression, we have seen how to apply the logarithm trick, to use the logarithm to evaluate indeterminate forms of the form 1 to the power of infinity, or 0 to the power of infinity, or infinity to the power of 0. I hope you understood the important problems in this exercise. If you have any questions, please mention in the doubt section. உங்களுக்கு எக்ஸ்பிளனேஷன் தமிழ்ல வேணா சொல்லுங்க, நெக்ஸ்ட் வீடியோஸ்ல நான் தமிழ்ல எக்ஸ்பிளனேஷன் போடுறேன். தேங்க்யூ.